Okay, for page 4 of integration, we're going to start with the fundamental theorem of calculus, which is basically just says that integrals are the opposite of derivatives. That if you know the derivative, that you can reverse it, and then also calculate integrals, which are area formulas. So let's write the fundamental theorem of calculus out. It's usually written like this. Oops. So you have like the integral sign, and you integrate from the left limit to the right limit a function. And the way you integrate it is you take you find out what its antiderivative is, and then you substitute in b, and then you subtract the antiderivative with a substituted in. Okay, and we'll see exactly what that means later. Now, here we have some variations on this part of the fundamental theorem of calculus equation. It has the integral from a to b of f of x equals, etc. And oops, I did forget to put one thing in between the equal sign and this. There is a dx, which basically says that the integral is done with respect to the variable x. Okay. Now, if you look here, there's some different things about, like here, instead of a to b, it has a to a. What happens when you do a to a? And if you do a to a, then you have basically f of a minus f of a instead of f of b minus f of a. So that's just 0, right? What about here? Here we have b to a instead of a to b. Now, if you have b to a instead of a to b, then you would have f of a minus f of b. And basically that's equal to negative of the original right side of the fundamental theorem of calculus. So it's basically saying that it's the negative of the regular equation. Okay, so you could reverse the a and b, and then you just take the negative of it. Now the next one, it has the integral from a to b, and then it adds it to b to c. And if you look at this, then you would say, oh, well, that's equal to f of b minus f of a plus f of c minus f of b. And then you could simplify that. You have f of b minus f of b, so that cancels out, and then you're left with f of c minus f of a. So that actually means it's the same thing as a to c f of x dx. Let's see, what else? This one here, we have f of x plus g of x. And if you have f of x plus g of x, and they say minus g of x also because they want to be more general. So if you have f of x plus g of x, and you have the antiderivative functions f of x and g of x in capitals, then basically what you have is you have f of b plus g of b, and you're subtracting out f of a plus g of a. Okay, and then you can see that these also cancel out. G of b, basically you can like rearrange these. So instead of having it like this, you could have f of b minus f of a, and you could group that together, and then you could add g of b minus g of a, and group that together. And if you group it like that, then you can see that actually you could have two integrals here, one going from a to b for f, and the other going from a to b for g. So you could kind of separate it out that way. All right. Now a to b, c dx. So for in this case, you could say, oh, well, f of b minus f of a, but actually f of x is just c. It's a constant c. So the antiderivative of the constant c would just be cx. So actually what this is saying is cb minus ca. So this is the same thing as saying c times b minus a. Last of all, if you have this, this is equivalent to c f of b minus c f of a, which is the same thing as factoring out c, which means it's the same thing as c, and then putting f of x from a to b of dx here. So we can rewrite this. We could say a to b, f of x, dx, like that. Okay? Alright, so those are all the different rules for fundamental theorem of calculus, which we're going to use in the next few pages. Number 1, use the fundamental theorem of calculus to find the area between the x-axis and y equals x cubed from x equals 0 to 1. So here we can draw a little sketch here, and basically x cubed between 0 and 1 kind of looks like a parabola. It's just a little steeper. And we're going to find the area under the curve, which would be like this area here. And so it says to use the fundamental theorem of calculus, so we're going to do an integral from 0 to 1, 0 to 1, of the function x cubed, and that'll give us the area. And so basically what they're saying is oh, find the antiderivative function, substitute b and a, and that'll give you the formula. So we know that the antiderivative of x cubed is going to be x to the 4th over 4 from the what we noticed in the last page. So it'll be x to the 4th minus, or of 4, and we're going to substitute in b, which is 1, right? So first we're going to put in 1, and then we're going to subtract out 0 to the 4th over 4. So that would be 1/4 minus 0 is equal to 1/4. Okay? How about c? So we're going to find the area between the x-axis and y equals square root of x. Y equals square root of x, remember, looks like a sideways parabola. So it would be this area here. And so it would be an integral from 0 to 1 of the function square root of x. And so the antiderivative of square root of x, we just found it on the last page. It would be x to the 3/2 times 2/3. Okay, and so basically we're going to put 2/3 1 to the 3/2 minus 2/3 0 to the 3/2, and subtract that out. We're going to end up with 2/3. Okay, and then it says to check the answers using technology. That's good to know how to do that. So we'll look at, we'll go to y equals, and we'll substitute in x cubed as the function. X cubed. Okay, and then we're going to do a second calc integrate function. And the lower limit, we're going to put x equals 0. And the upper limit, we're going to put x equals 1. And it gives us 0.25, which is that one right there. Now we're going to do square root of x. So instead of 3, we're going to put 0.5. And then we're going to do a second calc integrate. And we're going to say, oh, the limits are from 0 to 1. Lower limit 0. Upper limit 1. And it gives us the answer, 0.666. That's right. Okay. Number 2. Use the fundamental theorem of calculus to show that going from the left limit of a to the right limit of a yields 0. And we kind of already did this. The fundamental theorem of calculus tells us that if we can take the antiderivative and substitute in a, and subtract the antiderivative, substitute a, and that gives us 0. Okay? So basically what that's saying is, oh, you can have like any function you want, all right? And if you make the limits from x equals 0 to x equals 0, which is basically one on top of each other, a rectangle which is has a width of 0, then the area is also going to be 0 because the rectangle has a width of 0. Okay? All right. C. It asks us to explain f of x. If we put the reverse b of a, then we get the opposite. So if we reverse b of a, instead of having f of b minus f of a, we have f of a minus f of b. And we know that, like, if we have the regular fundamental theorem of calculus, what we have is f of b minus f of a, which is the reverse, right? So we have shown that. Okay, we already showed that up top anyway. And then this here we also showed up top. Remember, so we have the two antiderivatives f of x, g of x, right? And so basically this fundamental theorem calculus tells us that this would be f of b plus g of b minus f of a plus g of a. And we could regroup this. We could put f of b minus f of a plus g of b minus g of a. And if we regroup it like that, then we could rewrite it as two integrals. The first integral being f of x, and the second integral being g of x. And then basically what we've done is written it like that, right? Last one. Use the fundamental theorem of calculus to find the area between the x-axis and y equals x cubed. From x equals 1 to x equals 2. Okay, so this is a little bit different. Instead of like doing this region from 0 to 1, we're going to do this region, which is from 1 to 2. So let's write that. Instead of having 0 to 1, we're going to have 1 to 2. And we're going to have the function x cubed. And we remember that the antiderivative of x cubed is x to the 4th over 4. So we're going to have x to the 4th over 4, where x is 1 first, no, 2. And then we subtract out when x is 1. And so basically that gives us 16 minus 1 divided by 4, which is 15 fourths. Okay. And the other one is y equals x square root of x. And so again, instead of looking at the region 0 to 1, we're going to look at the region 1 to 2. And so the antiderivative of this is going to be x to the 3/2 2/3. And so let's write out the integration we're going to do. We're going to do from 1 to 2 of the function square root of x dx. And we'll first put the antiderivative with 2 substituted in, and then antiderivative 1 substituted in. And then that was going to be 2/3 times 2 to the 3/2 minus 2/3 1 to the 3/2. So that would be equal to, let's see, 2. This is going to be like not a nice number. So it's going to be square root of 8 2/3 square root of 8 minus 2/3. Okay? So we could find a number for that on the calculator, at least. It would be square root of 8, which is 2.83 times 2/3 times 2 divided by 3. Get 1.88, and then we subtract out 2/3, which is 1.22. So our area is approximately 1.22. And that's it for this section.